to something more fancy or even a villa with a pool. And if you don't take the time, to investigate what your customers actually want, then you might end up building this while your customer is expecting that. And then you have a conflict with your customer. It's really about expectation management. Talking to the customer, making sure you understand what they need and why they need it. What's interesting is that the why they need it is often more important. A customer can tell you, hey, I need this and I need a button down here, and when I click, something needs to happen. But if you understand why they need that button, it makes it much easier to think, of alternative solutions to help define new solutions. And if something isn't technically possible, it's easier to help the customer if you know what the business requirement is of why they want a certain feature. There are several ways you can do this. For example, to do a requirements definition for web applications, I always like to start with an interaction design. In interaction design, you basically create wireframes, and that can be anything from like a simple pen and paper thing to using tools like, for example, Axure here. And that makes it really useful. You just draw the screens without any layout. You just create a wireframe of the application. And what's nice about the wireframes is that you can use that as like a discussion subject with the customer. Because if the customer can see, what the application is going to look like, well, not actually going to look like, but what all the elements are, what all the features are in there, that really helps the customer think. Because what we see a lot in web application development is that the customer thinks they know what they want, but once you've built something, they actually know what they want. Now I really wanted this, or yeah, it would be nice if it was that way. And you can prevent a lot of that by just creating wireframes, and talking about the application before you start coding. Other really useful things are flow diagrams. I'm not sure if it's really readable on the left, but it's like an example diagram of a website where you have more or less like a sitemap. What are the elements on an application? What are the elements in the site? Makes it really easy to visualize things. Because pictures say a lot more than, big specifications with a lot of text. Next thing to look at is architecture. Architecture is also important because if you just start stacking bricks, if you just develop an application without thinking about the architecture, then a little gust of wind will come by and your whole building will collapse. So you actually have to think about the architecture of an application. What are the performance requirements? What is the architecture? What is the environment the application needs to run in? It's really important to think about the architecture with scripting languages. You can do this with, for example, a technical design. Traditional software engineering principles like creating class diagrams, ER diagrams for data models. There are a lot of examples of things you can do, to describe an architecture and to discuss that architecture with the developers. What I always like to use is a UML tool, that you can just, easily create graphical representations of your architecture that you can discuss with developers. But even something simple as a whiteboard, with a few markers where you can just get your development team up to the whiteboard and just sketch whatever you're going to build. It helps a lot if you think about your architecture. Then what that, for example, prevents is that you run into performance issues later on or scalability issues. So really thinking about the architecture saves a lot of time during the rest of the development. It's also interesting to think about a few high-level architectures. Many people think that if you create an application with something like Ruby or PHP, you just start hacking away, you create a script that talks to your database, and that's it. That's not really an architecture. Popular architecture, for example, are the model view controller paradigm. How many of you have heard of MVC? About half, I think. Well, model view controller is actually a really good way of separating concerns. For example, in your model, that's where you implement your business logic. Everything that has to do with the business and with the business requirements is in your model. The view has everything to do with presentation logic. That's how data is represented on the screen. And if you separate those, if you keep your business logic separate from your templates, then it's really easy to change the layout. And it's also really easy to change business requirements without having to redo all the templates. Traditional applications where, for example, especially in PHP, where you have a big mix of things like HTML and PHP in one file and it's all one big bowl of spaghetti, if you need to make a change there, that's really hard. But by implementing the MVC paradigm, you can make that a lot easier. But the controller, finally, that's basically the glue that ties the model and the view together. Controller is basically what contains your application logic. So the controller basically says, hey, I'm in this state of the application, I need to display this template, and the user can click this button, and then that will fire off to the model. And basically the controller ties it together. But there are a lot of other architectures that are also worth considering. I won't go into detail on all of them, but for example, what's very popular nowadays are service-oriented architectures, where you divide your functionality into multiple services, which makes it a lot more easy to scale. If you have, for example, a service that takes care of your customer data, and you have a service that takes care of billing, and it's a lot easier to scale. For example, if you need to send out a lot of bills and you have performance problems there, you can easily scale that to, for example, bigger machines or multiple machines, whereas your other services still remain, on a simple box. By dividing things up into services and having those communicate, you make it a lot more scalable. The other two are also interesting. If you're interested in those, a good starting point is, for example, Wikipedia. If you just look up the page, on such an architecture, it really describes, how the architecture works, when to employ it, what the benefits are. That's really a good way to look at things before you start coding, to see if there's some high-level architecture that you can apply to your application. Well, the next step we need to look at is tools. With scripting languages, you don't need tools. I mean, basically, any scripting languages, and the only thing you need is Notepad, a simple editor that you can use to write software. But the thing with tools is that they make you more productive. It's a lot more easy if you have tools. You can get things done quicker and faster. For example, in development, the tools you should look at are IDEs. Things like Eclipse, Zen Studio in the case of PHP, Komodo in the case of, I think they support Perl and Ruby as well. Those are IDEs that basically add a lot of functionality that make programming more than just, writing code. And what's the most important features from IDEs versus editors like Notepad or TextMate is that you can do debugging and profiling. You can really step through your code. For example, in the top right, you see in PHP application where you just see a single line that's highlighted. You can just go through your code line by line, and it makes it a lot easier to debug an application. A lot of people that use editors do what I call alt-tab debugging. They write some code, they alt-tab into the browser. Well, it doesn't work. Alt-tab back into the editor, change something, and you do that back and forth a few times. IDEs make it a lot easier because you can just go line by line through your code and immediately see what is happening, and that saves a lot of time during development. Other things IDEs help with is, for example, syntax checking. Most IDEs support syntax checking before you run the code. The thing with scripting languages is that we don't compile anything. I mean, Java people are used to compiling things, and the compiler will tell them, hey, you got an error there, something is wrong there. But with scripting languages, we don't have a compiler that tells us that. Usually we only see if we have made a typo in a piece of text once we are testing it. Well, IDEs can really help with that because they can do syntax checking before you actually deploy the code. So it immediately tells you visually, much like spelling check in Microsoft Word. It's just underline something and say, hey, there's a problem here. This is a variable that you haven't used before, or you miss a semicolon somewhere. That's really useful. And they also help with cross-referencing and navigation. If you develop scripting languages and you develop enterprise projects, that are a bit larger, then you're really losing a lot of time searching through code. You have a function here in a file, and you need to edit it, and you can't remember really, what file it was in, so you have to search a lot. Basically, IDEs help a lot with that. You just double-click a function call, and we'll immediately jump to the right file in the right project to open up your function. So tools are really, useful to increase productivity. You don't need them, but you can get things a lot done, get things done a lot faster. Other tools that are interesting is source control. If you are working with a bigger project, and if you work with a lot of developers, and you're not using a source control system, then what usually happens is that somebody makes a file, makes a change in one file, and somebody else makes a change in the same file, and you overwrite each other's changes, and you lose code, and people are in the way of each other all the time. With source control systems like CVS or SVN, or if you're using Microsoft technologies, Microsoft Visual Source Safe, really makes it easy to collaborate on software because basically the source control system takes care of all these conflicts for you. Basically it tells you if I make a change in this file and somebody else makes a change in that file, source control software can basically merge those changes and make sure that nobody overwrites each other's changes. And if there's a conflict, if you both change the same line into something else, it will just tell you, say, hey, I've got these two versions of the code, which one is the right one? And it will actually help you know to prevent these conflicts. A fourth tool that is really important is documentation. People write a lot of documentation in their code, but code documentation is not always easily accessible. You know, you have functions in a file and they are, documented. These are a set of tools that can help you, create actual documentation from these source code comments. And they are there for most every languages. except for Perl, there's only something that can make like an object-oriented documentation of a system, because basically it said Perl is too difficult to parse to create an actual API documentation generator. But the others really have API documentation generators that just create a set of HTML files with all your